Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this session, we will discuss about tutorial 1, electrostatic. So basically, I will divide this tutorial into two parts lah. For the first part, we discuss up until subtopic electric field. So for the first question, they give you two charges with a different magnitude. So you can see here, one is 4Q, another one is Q. So this one has a larger charge compared to the another one. So they want you to they ask you what is the difference about the force. Okay, so if you are looking at the formula, you have a formula of F equals to KQQ over R square. So if you are only looking at the magnitude, it doesn't matter whether that one is on Q1 or on Q2, it still has the same force. So the answer would be either C or D. Now you have to determine the direction because this one, in this case, you have the same charge, so it will try to repel one another. So in this one, it will push in that direction, and this one will be in that direction. So you can see clearly from this one, the force has the same magnitude but in opposite direction. So the answer would be C. Okay, next one, question number 2. Two positive charges equal in magnitude are separated as shown above. In which location would the electric field strength be 0? So now they give you equal charge here and on the left side and on the right side. This one and this one. So they ask you at what position the electric field strength to be 0. So if you want electric field strength to be 0, the idea is that you want one electric field strength in one direction, another one in the opposite direction, so that it can cancel out. So if you are looking at position 4 and 1, over here, if I want to draw the electric field, let's say I label this one as A and charge B. So if I want to draw the direction of electric field due to A, it will be in this direction. Okay, due to B, it will be in this direction as well. Because this one positive, so it going away ataupun outwards from the charges. If at position 1, then the electric field will be in that direction and that one. So this one, if you are looking at the net electric field over in at 1 and 4, you will see that it wouldn't be 0. It couldn't be 0 because it is in the same direction. So the only two possible position would be either 2 or 3, because let's say at 2, then the direction would be in this direction due to B, and in this direction due to A. Okay. So between 2 and 3, because the charges is the same, has the same magnitude, so you will expect electric field to be the same at the middle point. So the answer would be 2. Okay, electric potential. Okay, so you have several answers here: increases, decreases, remain constant, or 0. So remain constant wouldn't be true lah. That one I can cancel out straight away. Now if you guys still remember the graph that I show you, we have two types of graph. One due to the positive charge. So if I have a positive charge, then the graph would look something like this as it goes away from the charges. This is potential against R. It would look something like this. This one didn't touch, and then this one for negative charge. You have something similar but from the negative part. So actually you can see that both of these, this one is decreasing, so this one is increasing. So it could be either A or B, but I think the most appropriate one would be approaching 0. So I'm going to add a word over here. Approaching 0. So the answer would be D. label this one with the symbol of V and R. Okay, for the next question, question number 4. An electric field due to positive charge is represented by figure 1.3. Between which of the following 2 points does the electric field do zero work on a moving charge? So, if you are looking at the formula of work is equals to Q naught delta V. So, the Q naught is actually the charge that is moving. So, that one is constant. The difference here would be from delta V. So if you guys remember about equipotential lines, if you have on the same line, example like C and D here, so you can see that C and D is basically on the same line. So that means that it has the same magnitude. So I can write V C equals to VD. So let's say it is moving from C to D, example. So the work done would be Q naught V final, which is at D, minus V initial, which is at C. Since both of this is the same, then the work done would be equals to 0. This part is 0. So the answer would be C and D. So basically, if you want to have 0 work, you have to pick 2 points on the same line. Okay, C and D lah. There's no other choices. Okay. Question number 5 shows some equipotential lines distributed in a space. A charged object is moved from point A to point B. So here it's already said that it moved from A to B. Again, formula for work is Q naught delta V. And then it should be Q naught final minus initial. Okay. And then actually you have to count it one by one lah. So for the first one, delta V, if you are only looking at the delta V, is equals to 20 volt. The second one is delta V equals to 20 volt. And then the last one will be 20 volt as well. So even though it has a different numbers over here, but delta V is the same, so you can say that if Q naught is the same, then the work is done is the same. So the answer would be C. The work done is the same in figure 1, 2 and 3. Okay. Question number 6. Okay, 3-point charge. Okay, so they give you 3 different points. Negative 1 coulomb, positive 2 micro. Okay, this one got unit. Let's write it over here. Okay, calculate the resultant force acting on charge X, Y, and then Z. So I'm going to do only one. I'm going to show you one, and then the rest you can do it yourself. In this case, I'm going to show you how to do at Z. The first thing that you have to do is that you have to do a proper free body diagram. So free body diagram, if you are doing you're focusing on Z here. Okay, you want to draw free body diagram at Z. So here, maybe I can redraw it over here, then I can redraw it in the next page as well. So over here, if you're focusing on interaction between Y and Z, so it is basically force due to Y on Z. So you can, at the moment, you can basically ignore this part lah. Yeah, X2 you can ignore. So if you're looking here, then you will see that positive and positive charge, so equal charges. Same polarity of charge, so positive and positive, so they will push away. So direction will be in this direction. So this one will be F due to Y on Z. Okay, so Z and X opposite charges, so we will attract. So direction will be towards X. So this would be F by x on z. So you have two force, one to the right and one to the left. Okay, so here this is the drawing lah, and then this is just the information that from you can get from the question here. Micro, you just change to SI unit. Remember, because basically if you want to solve this one, you have to use F equals to K QQ over R square. Since you have K constant, which is in SI unit, so all of the formula need to be in SI unit, especially the radius, sorry, not radius, the distance between two charges. So I change straight away to meter, so this one already in meter. Okay, and then you can calculate separately for F due to X on Z. Okay, from this diagram you can see clearly lah. This one to the left, you just substitute all the values Q, X and QZ, and then substitute the distance separation here, and then you get the answer, and then this one is to the left. So normally we write this one to help us to answer the follow-up questions lah. So it will be easier if you just write the direction. Actually from the diagram is enough for this case. Find the answer you have to write, but this one in between calculation. Okay, and then FYZ, you can see here, to calculate you just have to substitute all the values, remember here in meter, and then find the answer for YZ to the right. So you have two force, one to the right and one to the left. If I want to find the net force at that point, this one is point X, sorry, charge X. So normally we do right minus left, because right is positive and then left is negative, that's why it becomes right minus left. So if you have more than two charges, so you just have to add up all the forces acting on the charge. Okay, tambah je semua, don't worry. And then this one, find the answer. Because this one is positive, it means that the direction is to the right. Okay, because you already assume that to the right is positive and to the left is negative. Okay, moving on to the next question, question number 7. Okay, here in this case they give you 4-point charge at the corner of square as shown in figure 1.6. Determine the magnitude and direction of force exerted on charge Q2 and Q4. Again, I'm going to do only one example. So in this case, I choose 4. So if I want to do at 4 here, first thing first, I have to identify how many forces at 4. So if you compare with 4, we have 3 other charges. So you will expect to have 3 force at charge 4. You have to determine the direction, draw the free body diagram, and then determine the distance between the charges. Okay, free body diagram will look something like this. Okay, how do I get that one? I'm going to show you over here. Okay, this one I think by now you guys dah mahir kot. So Q4 and Q2, opposite charges, so they will try to pull towards Q2. Q4 and Q1, opposite charges, again pull towards Q1. Equal charges between 3 and 4, so pushing away. So we only focus the force at 4, because we want to calculate the net force over here. First thing first, draw the free body diagram, identify all the forces, and then just label it properly, so that you don't get things mixed up. So this one is F due to 2 at 4. This one is F due to 1 at 4. And then this one is F to the due to 3 at 4. Once you determine that, the next one you have to determine the distance. So for this one is 0.1, between 2 and 4, between 3 and 4 is 0.1 as well. Between 4 and 1 you have to use Pythagoras, 0.1 square plus 0.1 square root. The next step, you will like to calculate each one of these force, calculate the magnitude for each one of these. So because this one, previous example, we have two forces that is on the same axis, so you can simply add or minus. But if it involve more than one axis like this one, okay, this one F34 is at x axis, F24 on the y axis, and F14 is between x and y. So first thing you have, after that you have to resolve F14 into x and y, then only you can add y component and then x component and then find the resultant and direction. Okay, this is how you solve it. Draw the free body diagram. I got this one as 45 degrees because this is basically a square, so this direction will be 45 degrees. If this one is not square, then you have to put theta over here. This one you have to put theta, and then maybe you can do tangent theta, opposite over adjacent. Okay, this one just the information gathered from the questions. I list down the distance between the two charges. So in exam, maybe it's best if you do it like this as well. So R14 is the one that I'm talking about. So you have to take Pythagoras and find the diagonal distance. Okay, and then you calculate separately F14, F24, F34. Find the magnitude of force. Okay, so this one you can write the direction as well if you want, but after this you're gonna put it inside a table anyway, so I put a table straight away. So to add vectors, you have to add the one on the same axis only. So y component and x component you have to do separate lah. F24, that one is actually to the upwards, so you only have positive y here. Yeah. For F34, that one is to the right, so you only have x component. The only one that you have to resolve is F14 here, the first one here. So I resolve. So x component normally we write cos, and then y component we write sine. But since this one is 45, you will get the same answer. But be careful here with the sign convention. F14, if I resolve, then I have F14x in this direction, F14y in this direction. Okay, so you can see that I don't know why my pen's like this. I'll try to rewrite it again. This one is y component. So y component is positive because it's pointing, upwards, and x component is negative because it's pointing to the left. And then you just have to add up. You just have to add up like this and add up over here. Include the negative sign, then you should get these two answers. Okay, this one is for x component and y component at 4. Okay, after that you can find the magnitude. So I just redraw the vectors, the final one, that one, the resultant, y component and x component. So you will expect the net force will be in this direction. Find the magnitude for first. Okay, square and take the square root. So here I got this one, and then to calculate theta, just use tangent theta, y component over x component. Okay, try to redraw this one so that you get the idea where the theta is. So here you can see clearly it is actually above positive x axis. Okay, question number 8, they just asked you to sketch. This one you can refer your notes. So equal charges, same magnitude, so they will try to repel. opposite charges, different magnitude. This one is slightly bigger, so this one double than the another one. So this one, you can see that the electric field line seems like overwhelmed the another one. And then the numbers of line, you can see that the one with the bigger charge is closer together and has more electric field lines. No? It indicates that the magnitude here is bigger. Okay, direction, normally we draw arrow on the electric field lines. No? Like this. Okay. Okay. This one pun sama lah. Anyway. Question number 9. So question number 9, they give you 2-point charges Q1 and Q2 arranged at two opposite corner. So Q1 and Q2 at opposite corner. What is the magnitude of the resultant electric field strength at O produced by the two charges? Okay, so I just write it over here. So I have -4. And over here is 8 microcoulomb. Distance is given. Maybe you can try to change to SI unit and then find the electric field strength at point O. Okay. First, you have to draw direction of electric field strength due to Q1 and Q2. Maybe I can draw it straight away over here. This one is, okay, electric field, you have to look at the sign for charge. So negatively charged, so we will try to move towards the charge. Okay, this one is E1 at QO. Okay, this one is E2, sorry, positive, so moving away. Okay, like that, E2O. Okay, so actually, if you're focusing on this one, it will produce electric field like that, moving away. So if you're not sure, you can always drag this line up until here and you will see that it is actually to the left. For this one, it's the same. You can try to redraw if you're not sure. So again, this one is pointing towards Q1. Okay, change to SI unit like this one. And then you just have to use the formula KQ1 over R10 square. Substitute all the values. You get the answer over here. That one's the magnitude. And then you just write down the direction as well. So this one is based on the diagram that you draw, downwards and to the left. After that, you can find the resultant electric field at point O. So this one, you don't have any vectors that is not on the axis, so you can straight away use this one lah. Let's say if you have one in that direction, then you have to resolve that one. Example, if you have like this, right, electric field, then you have to resolve that one first. Okay, once you get the magnitude, find the direction, redraw the diagram here, and then since this one is the X component and Y component, so you will expect the net will be in this direction. Okay, and from your diagram, you can calculate the theta. The answer, you just state it should be below negative X axis. Don't forget that one. Okay, I think it's finished already. Okay, so for this session, we stop here, and then for the next question, we continue at a different video. Okay, thank you everyone.